Alright, so in this video we're going to be talking about approximating area under a curve. Alright, so we'll start with an example. Suppose we want to find the area under f of x equals x squared from x equals 0 to x equals 1. Let me sketch this area. So we have standard quadratic here, y equals x squared, or f of x equals x squared. And we're looking between 0 and 1, so this area right here. I want to find that area. Alright, so we can approximate this area. We can approximate this area with rectangles. And these rectangles are going to have heights determined by the function outputs. Alright, so let me show you what I mean. We're going to redraw this picture with little rectangles from 0 to 1. I'm going to choose 5 rectangles. So I'm going to divide this interval into 5 little sub-intervals. And then I'm going to draw rectangles whose heights are determined by the function outputs at those 5 points. So the 5 points that I chose are the right endpoints. These are the right endpoints of the sub-intervals. And these right endpoint rectangles are going to give us an overestimate. This area is going to be an overestimate. Alright, so let's make a table to keep track of everything as we find the area of these rectangles. So we're going to have 5 rectangles. So we'll number them 1, 2, 3, 4, 5. We're going to find their base width. So the base width is going to be 1, this entire interval, divided by 5, or 1/5. So the base of each of these rectangles is going to be 0.2. Then we're going to look at the right endpoints of these sub-intervals. Right endpoints. So the first endpoint is here. It's 0.2. The next endpoint is there. It's 0.2 over from 0.2, or 0.4. And then continuing this process, we get 0.6, 0.8, and 1.0. All right, now let's find the heights of these rectangles. So we're going to take these right endpoints and we're going to plug them into the function to find the heights. So if we put 0.2 into the x squared function, we'll get out 0.04. If we put 0.4 in, we'll get 0.16, and so on. And then we can find the area of each of these rectangles by multiplying the height times the base. So 0.2 times 0.4 equals 0.008. And continuing this on, we get 0.032, 0.072, 0.128, and 0.2. And then if I add up all those areas, I'll get 0.404. So the area is approximately this value. Now you might say this is an overestimate, so what we should do is we should do an underestimate, or something in between. So let me just repeat this process, but instead of doing the right endpoints, using the right endpoints, I'm going to use the left endpoints. Alright, so we have our x squared function, we have 1, and now we're going to use the left endpoints, 1, 2, 3, 4, 5, and we'll use those left endpoints to construct the rectangles. So just repeating this table, we'll have 5 rectangles, 1, 2, 3, 4, 5. Their base width will still be the same. It'll be 0.2. but now we're going to use left endpoints. Okay, so the first endpoint is going to be at 0, and then 0.2, 0.4, 0.6, and 0.8. Putting those into our function to get the corresponding heights, we'll get 0, 0.04, 0.16, 0.36, and 0.64. And then multiplying the base of each rectangle times its height, we get the area. So we'll get 0, 0.008, 0.032, 0.072, and 0.128. Adding that up, we get 0.240. That's our approximate area here. The area of those rectangles. And somewhere between these two values is the correct area, because this is an underestimate. The second value is an underestimate. This is an underestimate. And this is an overestimate. So if you wanted to get a really accurate estimate, you could take the average. So the best estimate here, given these two numbers, would be the average, 0.440 plus 0.240 divided by 2, which gives us 0.340. And the actual area, which we'll see later on how to calculate, the actual area is going to be 0.333 repeating. So this is pretty good. This is pretty good estimate. All right, let's do another example. Call this example 2. So let's, in this example, approximate the area under y equals 4 minus x squared from or over x equals 1 to x equals 2. And we're going to use 4 rectangles. And again, we'll use right endpoints. We won't do left endpoints this time. All right, so let me draw the picture. So this 4 minus x squared looks like this. Comes down, it intersects the x-axis at 2. And we're only interested in the part of this graph, the part of this curve that's above 1 to 2. So let me draw 4 rectangles. We're going to use the right endpoints of these rectangles. So there'll be 1, 2, 3, 4. So these will be our 4 rectangles. Our last rectangle has no height, so it's a 0 area rectangle. And now we do the table like we did in the last problem. So we have rectangles, 1, 2, 3, 4. We have the base. Again, this interval is 1. So the subinterval is going to have length 1 over the number of rectangles, 1/4, which is 0.25. So our base is going to be 0.25 for each rectangle. And then we'll use the right endpoints to construct the heights. And this first right endpoint right there is 1 plus the width of the subinterval. So 1 plus 0.25, or 1.25. And then we just keep adding 0.25 each time. We'll get 1.50, 1.75, and 2.0. Then we'll take these right endpoints, we'll put them into the function. So we're going to take each of these values and evaluate them using this y equals 4 minus x squared. When we do this, we'll get 2.4375, 1.75, 0.9375, and 0. All right, then we take these heights, we multiply by the base and to get the area. I'm going to round to 3 decimal places here. So my first number is going to be 609 when I rounded 3 decimals. I'll get 438, 2, 3, 4, and 0. And then adding those up, I'm going to get 1.281. So I would say the area is approximately 1.281. All right, so now let's generalize what we've done in the last two examples. Let's generalize this for f of x over x equals a to x equals b. Okay, let me sketch just a generic function here. So here's our f of x, here's our a, here's our b, and we want to approximate this area with a bunch of rectangles. So let's draw some right endpoint rectangles here. And we want to do this in general, so I'm going to not draw all the rectangles. I'm just going to say what we're going to have n rectangles and then do this little dot, dot, dot in between. N rectangles. Okay, so let's do what we did earlier and let's make a table. And we're going to have some dot, dot, dots because we're not going to be able to write every rectangle. We're doing this in general. So I'll say 1, 2, 3, dot, 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 n. And then we'll find the base of each, the right endpoint. We could use left endpoint, but I'm going to use right endpoint here. The height, and then the area. So the base, well, we get to take our interval, which is b minus a, and we're going to divide it by n to find the width of our little rectangle. So the base is going to be b minus a over n. Now we look at the right endpoint. The first right endpoint here is one subinterval width over from a. So this point here is a plus b minus a over n. And then the next right endpoint is going to be a plus b minus a over n times 2. Times 2. Because I'm going to move two subintervals over from a. So I'll have my first right endpoint is a plus b minus a over n. My second one is a plus b minus a over n times 2. And then my last point is over here. That's going to be a plus b minus a over n times n. Because I'm going to go over n subintervals. And you can see that this works out because if you do the math here, you cancel the n's, you get a plus b minus a, which is just b. So the last endpoint is indeed b. That's correct. Okay, so now we take our right endpoints and we put them into our function. Our function's given by this f of x. So we're just going to take all these values, these expressions, and put them into f. And then to find our area, we just take these heights and multiply by the bases. We'll get f of a plus b minus a over n, all times b minus a over n, and so on. Okay, and then if I want to find the area of all the rectangles, of all n rectangles, I just sum these values. So I'll have f of a plus b minus a over n times b minus a over n plus, and then all the way up to f of a plus b minus a over n times b minus a over n. Okay, so this is a formula for the approximation of the area under a curve. And this gets a special name. This is called a Riemann sum. A Riemann sum. It's an approximation for the area under f of x from x equals a to x equals b. All right, I hope you found this video useful.